Good morning. We'll start with last unit, that is transaction management. Okay, so how do we manage the transaction in the bank? Can anyone respond? How many transactions you can do in your ATM per month? Can anyone respond? How many transactions you can do in the bank? Anyone? How many transactions you can do? Can anyone respond how many transactions you can do in your bank for 1 month?
Ma'am, in ATM will get 8 times free transactions, ma'am.
8, in the same ATM or in a different ATM?
No, ma'am, like any ATM.
Mm.
After that, we have to pay charges, ma'am.
Okay, till 5, as per my knowledge, 5 transaction it is free. After 5 transaction, you will be charged. Okay, so again, if it is within the same bank 5, if we are doing with some other ATM transaction, then it is only 3. So that's what the transaction limit. Why do they limit? What is the reason for limiting? Why only 5? Why not more?
Security purpose.
Security purpose. Anybody else? Okay, one reason they're saying security. Why they don't want to do so many transactions? Okay, so this was earlier. Now how is your transaction? Everything Junja told for security. Okay, now you have your other accounts also where the security is increased. You will get a OTP. In the same way we would have done for the transactions also. Why they should give only 8 transaction allowing for bank, or 5 transaction free if it is more than they charge? Yes. Is it only at bank we have transactions? Now you are doing, how many of you are shopping for Deepavali? For Diwali you are doing transaction? What is the online tool, online app you are using? How many of you are using Amazon? Anybody using Amazon app? Okay, Flipkart you people are using? And which are the other apps which you people are using for shopping? How many of you purchased new items for Diwali? Did you purchase? Okay, not you, at least your parents. Your parents purchased. How many transactions you can do in Amazon? Is there any limit for Amazon?
No, ma'am.
No. Why in the bank then they are doing transaction limit? Why they are doing transaction limit only for bank? Why not other people? The same way, right? The same thing only, right? Because we as a software engineers, we know how the transaction, how the backend is working, right? So because we are learning DBMS, then we know when we are doing for Amazon, Flipkart, why can't the same can be applied for banking also? Why they are charging?
You have to maintain records and
Amazon people will not maintain the record.
maintain.
Then they also will maintain, see, each and everything. So today they have dispatched, where is today your item? You can see everything in the Amazon, or as well as in the online shopping apps. Then why? Okay, so what we are doing, what's the difference here and in other thing is, in online shopping, so that is temporary. So if after you deliver, your item is delivered to you people for any customer, it is not mandatory for them to keep all the data. Whereas at the bank, even if you go and ask for 5 years, they should be in a position to give your transaction. Yes. So for that reason, they have limited. Whereas this Amazon people, if you go back and ask after 10 years, what you have purchased, they will not keep all the details. It is not required for them to keep because they have already done. Only till the expiry date they can keep. Usually the items expiry date will be 1 year or 2 year, maximum maybe 5 years. Not more than that. They want to keep their database constant or keep it safe. They can delete as soon as their work is done. They can delete, but that case is not with respect to the bank. So because from the beginning of the bank to the end, they have to keep everything tracked. That's the reason the bank people won't allow us to do more transaction for a month. So that's what we will be seeing in the in our next chapter, that is a transaction. Then as a database engineer, because we are learning database management tools, you have done some program, 5 programs, that is SQL. And now how to manage the database. So today you would have done some project on the database. Let us assume that you have given with database for creating all the employees of BMSIT college, their salary details. Okay, so because maybe you would have a chance of changing, or if I say your marks, IA marks database, you are keeping track. There are the chances or tendency to change or increase your marks in the database. That should not happen. So that's what here we'll be seeing in the transaction management. So what is transaction? So concurrent execution of a user program is essential for good DBMS performance. Okay, how many people will be using Amazon for 1 minute? At least now you can see in Diwali time, maximum people will be using. Okay, suppose if you got your result, which your result is announced for second semester, then how many people at that particular time will be accessing the server? There will be many people who will be accessing the server at that particular time. So in that case, concurrency means parallel. So now how many of you are in your class? 50. So like this, imagine in Karnataka, how many MCA students are there? How many MCA students are there? Can anyone say how many MCA students are there in third semester? In VTU? Any idea? Can anyone say how many VTU students are there in MCA third semester? 3,000, 4,000, 5,000, 10,000? Okay, let us make it as for at least 10th standard, maybe lakhs of people, students will be there. Suppose if they want one particular time, they want to see their results. Then concurrently, everyone starts using the database. Then that's what here concurrency in the DBMS. So user submit transaction and can think of each transaction as executing by itself. So we submit the transaction. Sometimes you would have seen in your ATM card the transaction failed. Try after some time. So even now also, if you change the password and your PIN is not working. So suppose you forgot old PIN and you give some other PIN, how many times you can try? You can try only 3 times, not more than that. If you try more than that, your that particular thing will be blocked for 24 hours. So that's how here the transactions are very important. Let me say that because we are using ATM nowadays, or your apps also you are using. Now you have sent the amount for Amazon. You have sent amount to the Amazon. And before they send you reply, they send you, okay, we have accepted. Before they send, we have accepted your amount, your network got disconnected. And what will happen? What will happen in the database? You have sent the amount to the Amazon. Till they didn't accept, by that time your network got disconnected. Then what is the option there? What's the option there? What they have to do? So then it becomes very difficult to keep track, because either your transactions should complete or it should not complete. That's what we'll be seeing in this chapter. So first one is a concurrency in the DBMS. User submits a transaction and can think of each transaction as executing by itself. Concurrency is achieved by the DBMS, which interleave actions, that is what reading or writing of database objects. So now suppose, let me say that I have given one question paper and I've asked you people to edit that question paper. Now Arjun is editing. When Arjun is editing, can Arbaz also edit? It should not accept that. Editing by two people at one time should not accept. In the same way, when I send the question paper, you people can only see. You cannot change anything. That what type of mode it is, that is read mode. So the same way, write mode also we can do. We can share Excel sheet and we may ask you people to enter whether you are wishing to come to college offline or whether you are interested only in the online. So we can do so many things. So that's what is a read and write option. So concurrency is achieved by the DBMS, which interleave actions, that is read write of DBMS objects of various transactions. Each transaction must leave the database in a consistent state if the DBMS is consistent when the transaction begins. So that's what here concurrency in the DBMS. So DBMS will enforce some ICs depends upon the transaction, whether the transaction should be there, and declare in the create table statement. So beyond this, DBMS does not really understand the semantics of database. Example, it does not understand how the internet on the banking account is computed. So issues with the concurrency is effect of interleaving transaction and crash. So now what may be effect? Suppose if I leave. So now suppose let me say I am taking a class for you and there is some internet problem with me with my laptop, or there is internet issues. Then what will be the problem here? You people will be listening and I am not able to say anything. So this is what is called interleaving. So we are leaving in between and checking out how you people are able to execute. So that is one problem what we see, the effect of interleaving transaction and crash. So then next we have something called as a atomicity of transaction. A transaction might commit after completing all its action, or it could abort, or to be aborted by the DBMS after executing some actions. Very important property guarantee by the DBMS for all transaction is that they are atomic. That is, user can think of exact acts as always executing all its actions in one step or not executing any actions at all. So what do we mean by atomicity is, so suppose if we say that you people, you were being asked whether to execute or don't execute. So you will say, as in the lab session in your this one, you will be saying that whether your program, you will say sometimes, madam, program only one query is executed, other query is not executed. Then it becomes so difficult for us to say whether your execution is done or not. So that's what here we have seen in the transaction in the functional dependency part. So in the functional dependency, even you can see how the database should be designed. So what did we see in the functional dependency? We have seen there were some insert anomalies, deletion anomaly, modification anomaly. So same way, even with the transaction management also, we have problems. So like that's what just now I told. You have sent money to your Amazon. Means you have transferred from your app, either maybe banking app or from any money paying apps, and you have transferred amount to the Amazon. Maybe let us assume that you have purchased some very good item, and that let us say you have purchased a mobile and it is charging about 30,000, and you have transferred 30,000 to Amazon account. Then your network got disconnected. Then what we have to do? What is an option for us now? I've transferred, but they didn't acknowledge us. Then how will you say whether the amount will come back or whether the amount is gone? Because it is not complete. It is still half. But then your internet got disconnected. Yes. So same way here we have seen in the earlier classes in insertion anomaly, deletion anomaly, and modification anomaly. The same way here also in the transaction, atomicity means what? Either you can complete the execution or you don't execute at all. So that's what here. If you have done transaction, if you have sent the amount, then definitely after your internet gets back, they should reply you back. That is what is called as a atomicity. What do we mean by atomicity? Atomicity means either the transaction should be done completely or it should not be done. It should not be done only. So that is what is transaction management says to us. Same way what we have seen in the functional dependency insert anomaly. The same way in insert anomaly what we have done, two tables were combined. If two tables are combined, half of the table if you are inserting, half you are not inserting, then what you will insert in the other half? That's what insert anomaly. Same way we have seen about deletion, we have seen about the modification. Same way even with respect to this transaction. So what is this transaction says to us? Transaction management, issue of interleaving transaction and crashes. So then atomicity, what do we mean by atomicity? Just now I told atomicity means either you completely do the execution or please don't do the execution at all. So that's what is called as a atomicity with respect to any transaction. So the transaction might commit after completing all its action, or it could be abort or to be aborted by the DBMS after executing some actions. A very important property guaranteed by the DBMS for all transactions is that they are atomic. That is, a user can think of act as always execute all its action in one step or not execute any action at all. So that's what here, what is atomicity says to us. Either you execute completely all the thing or please don't execute anything. Let us take one small example. Consider the two transactions. So one transaction T1, another transaction T2. In T1, what we are doing? A equals to A plus 100. So there is one variable called as A. Already something is there in that. We are adding for A 100. Then B is subtraction. For variable B, some value is there in B. We are subtracting B from 100. That is one transaction. One more transaction, multiply 1.06 to variable A, and for B also you are multiplying. So intuitively the first transaction is transferring $100 from account A to account B. The second credits both the accounts with 6% interest for A as well as for B. So there is no guarantee that T1 will be executed before T2 or vice versa. So how do we say whether the T1 will execute first and T2 will execute later? We cannot judge whether T1 will execute first or T2 will execute next. If both are submitted together, so both of the things are done at the same time, then which one should be done first, multiplication or plus addition, or subtraction or multiplication? Which one should we do? However, the net effect must be equivalent to these two transactions running serially in some order. So we specify which order we have to do. So that's what is, in this case, you have transferred 100 rupees for account A and you have subtracted 100 rupees from account B. Then that is what one complete transaction. Another transaction, multiply 6% amount to transaction A as well as multiply 6% transaction to B. So then that's how here T1 and T2 will be done. So consider the possible interleaving schedule. That is, so let us see. Now we are not doing parallelly. We do it this at this time. So the same way like your timetable. So what we have done, all subjects 31 in your semester, you have 31, 32, 33, 34, right? And 35, 5 subjects you have. One is elective. And these, all 5 people can take at the same time? No. Then what we have done, at each hour, one staff person will be taking the class, because all 50 cannot be attending all classes at same time. That's the reason one. Same way, here scheduling. So what did we do? We have scheduled the consider a possible interleaving, that is scheduled. So then T1, A equal to A plus 10. We are adding. After adding, do the second transaction, that is 6% add to account B. So then after this, then subtract from D. Then multiply it to B. So this is what you can see. Consider a possible interleaving or scheduling, that is T1 and T2. This is okay, but what about if we are doing something like this? If I am doing adding 100 rupees to account and giving interest for both, then subtraction. So the DBMS view of the second schedule, that's the same thing. Read, write, read, write, read, write, or read, write. So what we have done here, the DBMS in DBMS view, so you have to read a value from A, then write 100 rupees to that. That's what read, write. So in this case also, read what is there in A and write 6% to account A, as well as read from the account A and add or write 6% to the account B. So that's the reason this second one is a view in form of DBMS. What we are doing, reading a value from the account, writing a value. Writing means what? Changing. So earlier some value was there in A, add 100 rupees. Adding 100 rupees means what? Writing. So read what was there in A. Let us assume there was some 100 already present in A. So that's what read is. So 100 plus 100, 200. That should be again written to A. So this is what is called as a read A, write A. Then the second one you can see. The same way here, we are reading as well as writing. So what we are reading, what is the value of A? We are reading. Then for that multiply 6%. Then what we are doing, we have to write. In the same way, for B also, so read B and write B. So that's what here, this we have done. So the same way, here also, B equal to B minus 100. That's what read B, then write B. So that's what here, this is how we are doing transaction 1 and transaction 2. So in the transaction 1, what we have done, this is with respect to calculation, A equal to A plus 10. And here you can see how the transaction is being done. Transaction 1, one statement is executed. Then transaction 2, second run is executed. Then again go back, transaction 2 is executed. Then transaction give break and come back. Same way here in your timetable, how is the timetable? It starts from 8:30, keeps going till 4:30. So 8:30 to 9:30, one class will be going on. After that, 9:30 to 10:30, there is again one more class. So 10:30 to 10:50, there is a break. Yes, same way here, what we are doing here. So one transaction is executed and take a break, take another transaction, then take a break, then another transaction. Like this, we keep doing the transaction. So T1 and T2. So this is with respect to calculation part. But with respect to DBMS, so what do we mean by with respect to DBMS? We just say whether we read or write to the account. Same way in your banking also. What we do, what you people can do in a bank account, either you can check your mini balance, or you can withdraw the amount, or you can check the statement, you can deposit. There are some operations available. So in the banking terms, they call it as a credit or debit. So now you would have seen we have a credit account, credit card as well as debit card. Debit card means what? only you can withdraw, take the amount. Credit card is what you can, the credit card bank people will give to you. So that's what a credit and debit. Same way here with respect to DBMS, we are calling it as a read account, write account, then read account, write account. So in which order we are doing, whether first you are writing or first you are reading. So same way, now I have sent you a question paper. In the second internals, you would have seen your question paper, all subjects question paper. So we have scheduled at that particular time. So what was the time schedule? 9:25 we have scheduled. But you think we have scheduled at 9:25 only. But at what time did you people reach, get the question paper? You got at exactly 9:28, 9:30. So this, what is this time? This time, 5 minutes is for sending the question paper through the network. So that same way here, reading an account and writing an account. For what? For one transaction. So in the same way, transaction 2, read a account, write a account, or read account or write account. So that is what is a 2 transaction, transaction 1 and transaction 2. So this is how we do this interleaving. Interleaving means what? Switching. So now I have to just show you people. So I can shift from one PPT to the another PPT. So now I have switched to one PPT called as a functional dependency. So I have left one more PPT back. So what is this is called? This is practically called as a interleaving. Same way, even with respect to your operating system or database, in database also, so we may leave sometimes the database improper. That should not happen. So that's what the atomicity says to us. What does the atomicity says to us? Atomicity says to us whether complete the transaction or don't complete the transaction. So that's what here atomicity says. So the same way you can see with respect to your functions in your C programming or any programming language, why do we use function? So you may use a math.h as a header file, and in your function you use a sqrt. So what is the purpose of using sqrt? Sqrt is a built-in function which is already written and we are including. So then if the execution was in the first line and if you are using sqrt, your cursor or your execution will go to that header file, execute that, and it will come back. So that's how here this one will be done. So this is what is called as a interleaving. So the same way when you are executing also, you are leaving and going back. Okay, let me take one more example. In your scanner, in your C programming or in your DBMS also. In DBMS, you have one more option called as a insert into table values ampersand A, comma, ampersand B, comma, ampersand C. Like this you enter. What is this ampersand will be doing? We are asking to enter the values through the keyboard. Yes, means what? You can see you're entering the values to the database. Until unless I press something in my keyboard, the values will not be transferred to the database. So this is called as a interleaving. So now what I'm shifting from one slide to another slide. So that's what is called as a interleaving. Okay. So next we have a scheduling. So what is scheduling? Scheduling means there are scheduling transactions. One is serial scheduling, another one is equivalent scheduling, another one is serializable scheduling. So what is scheduling? Schedule that does not interleave the actions of different transactions. So what is the serial scheduling? Like your sequence linear search. So what is we are doing in a linear search program? What we are doing in the linear search program? So in the linear search, what's the difference between linear search and binary search? In linear search, we have to go one item by another item, item by another item, another item by another item. Like this, we keep going till we reach for the end. Means whatever the item I want, that item I should get. Till then we go serially, one after the other. Okay. Binary search is what? You have some items to search where searching time to be reduced. Then what we do, we divide it into half, and we see whether what the element I want to search, whether it is present in this half or this half. That is what is a binary search. What did we do? What is the difference in linear search and binary search? In linear search, you have to search all the elements. Suppose if it is 100 elements, searching for 100 elements will be very difficult. Then, whereas in binary search, you're not searching for 100 elements, you're searching only for 50 elements because you have divided them into half. So, that is a thing. One more example in serial. So you would have seen in the olden days, maybe 30 years or 40 years down the line, we were having radios. Even now also, if you click on to FM, what we can listen, whatever the event they are doing, only that you can see. Means it is serial. So whatever they are giving you, we are in a position to listen all of them. That is what is a radio. Whereas in a tape recorder, what we can do, we can go forward. For which song I want to listen, I can go to directly there. I can listen there, that song. I can go back to that particular position any number of time. That's what is we have here serial scheduler. Serial scheduler is what? One after the other. Same example with your timetable. So not every day is first hour is DBMS. Not every day first hour you have testing. So like this, each one of them have given each one day first hour. Then based on their time slots, the timetable isn't prepared. And sometime you have lab, Python lab, sometime you have DBMS lab, sometime you have a ADA lab. Like this, you have different things. That's what is serializable. Next, a serial schedule that does not interleave. Does not interleave means we are not leaving in between. If I have started, I have to continue till 1 hour. So that's what here you can see. Even for the classes also, we have not scheduled for 10 minutes one class. It is scheduled for 1 hour one class. I cannot schedule 10 minutes DBMS, 10 minutes OS, 10 minutes testing. We have not scheduled like that. So that is what is similar like your serial scheduler. Schedule that does not interleave the action of different transactions. So then equivalent schedule, for any database state, the effect on the set of objects in the database of executing the first schedule is identical to the effect of executing the second schedule. Equivalent schedule, for any database state, the effect on the set of objects in the database of executing the first schedule is identical to the effect of executing the second schedule. So that's what is equivalent scheduling. Next one is serializable scheduling, a schedule that is equivalent to some serial execution of the transaction. Note, if each transaction preserves consistency, every serializable schedule preserves consistency. So that's what here, how the, just now I gave you an example of serializable, equivalent, and serial equivalent and a serializable. Same way with respect to your channels. So earlier, maybe some 40 or 50 years down the line, we were having only Doordarshan, where we were able to see whatever the Doordarshan people were able to release at this time. This event is there. At this time, this event is there. So at least when we were kids, we were the times was given. This 9 to 10 only songs will be given. So like this, that was there those times. But nowadays, as the technology has increased, you can see you can shift from one channel to another channel. So how many channels like this we have? We have multiple channels now. You can see maybe 500 channels we have. So that's how the technology has increased. And think how all these should be managed, how the database should be managed with respect to all these. This is what the challenging with us, how we can manage. Okay. So that's about a scheduling transaction. So anomalies Just now I told anomalies with interleaved execution. So I leave in between and go back, come back, like this is not allowed. So reading uncommitted data, that is write and read conflicts may be there, then that type of anomaly is called as a dirty read. So let us say we are reading some value from the account and I want to add, and that's what some people were giving me examples, or some people were saying when I asked you people to execute and show your lab programs, some people were saying me the reasons that you have not used a commit command, and because you have not used a commit command, full database whatever you have executed is not present in the database. Why the commit command you have not used? Because you've not saved. Because you have not used a commit command and it is not saved. So because again you want to retrieve, this is a problem. Same way here, when something like that happens, then what we have to do? Even now, yesterday also, because I'm taking, I'm teaching even for IS people also, and MCA lab also I'm teaching. So their program and your programs are different. Then I have to execute. Because I'm executing both the things, my tables are repeated and redundant. I have to change somewhere. So when I change somewhere, my query sometimes it will not turn up. So that is a problem what we have. So these problems we have to overcome with respect to transaction management. Okay, so I will stop here. We'll continue in the next class. So before that, let us summarize what we have done today. So we have started with the transaction management. In that, so what do we mean by transaction? Concurrent execution of user programs is essential for good DBMS performance, because disk access are frequent and relatively slow. So because disk access are frequent, so why do we have a cache memory in between? Can anyone say why do we have a cache memory? Heard about cache memory?
Yes, ma'am.
Why do we require cache memory? Why do we require cache memory? What is the reason that we require cache memory? How many types of memory we have? How many types of memories are there? Your hard disk is one memory. Your RAM is another memory. Then yes, how we can? Why? Yes, someone was answering. What I was answering? I was asking you people something. Yeah. What are the why do we use a cache memory? What was the reason for using a cache memory? We have a RAM, we have a ROM. So RAM is what? What is a processor?
Ma'am, between RAM,
yes.
between RAM and between RAM and CPU, you hello.
Yes, Ravi. Yes, Ravi.
Between RAM and CPU.
Yeah. So between RAM and CPU, whatever we have, that is what is a cache memory, right? Good. Why do we use? Why do we use?
For faster execution, ma'am.
Yeah, right. For see, whatever we keep in the hard disk, and hard disk fetching whatever we require and giving for the calculation for the processor, it is time consuming. And balance is not there between these two. One will be very slow, one will be very fast. To balance this, we are using a cache memory. Same way here also. That is what, because disk access are frequent. So we keep using it and relatively slow. It is important to keep the CPU humming by working on several user programs concurrently. So that's what we require. So then user program may carry out many operations on data retrieved from the DBMS. But the DBMS is only concerned about what is read, write from to in the database. So what is, just now I told processor, memory, all this. But with respect to DBMS, what we can say? With respect to DBMS, we can say either I can write to the database or I can change to the database, read, write. These are the only changes what I can do with respect to database. Creating, modifying, all these are there. But other than this, what are the operations we generally do? Read, write. These are the two with respect to transaction. Either I can read what is there in the database, or either I can write what is required in the database. So that's what here the first thing says to us. Then transaction is what? Transaction, the DBMS, is an abstract view of the user program, a sequence of read, write. So what is transaction with respect to DBMS? A transaction with respect to DBMS is sequence of I will read, I will write. I will read, I will write. Read, write, or read, write. So it can be any sequence. So then that is what is called as a transaction. What do we mean by transaction? Transaction means sequence. Now, how do your USN is there? There is some sequence. What is the sequence there? Order. So which order? Your alphabetical order. A, the student who is having A will be in the first. The student who will be having second will be in the second. So like this, they will be ordering them. So that is what is the sequence of your transactions. So I'll stop here. We'll continue in the next class. Let me take the attendance. It's a time 13. Asta, answer your attendance.
Yes, ma'am.
Abhinav, Aishwarya,
Present, ma'am.
Amresh,
Yes, ma'am.
Anu,
Present, ma'am.
Arbaz, Arjun,
Present, ma'am.
Ashok,
Present, ma'am.
Benita,
Present, ma'am.
Bhargavi, Bhavishya,
Present, ma'am.
Chaitra,
Present, ma'am.
Devmale, Diksha.
Present, ma'am.
Nirupama bande, ಒಂದೇ ನಿಮಿಷ. Diksha,
Present, ma'am.
Deepika,
Present, ma'am.
Deepika MB,
Present, ma'am.
Murli Krishna,
Present, ma'am.
Gangubai,
Present, ma'am.
Gudia,
Present, ma'am.
Harshit, Chunjar,
Present, ma'am.
Kavya,
Present, ma'am.
Kichor, Lata, ಎರಡು ನಿಮಿಷ. Lata,
Yes, ma'am.
Manisha, Manjunath, Nayana,
Yes, ma'am. Sayana, yes, ma'am.
Nilanjan, Nishant, Pavitra,
Present, ma'am.
Maithili, Priyanka, Pavan, Akash,
Present, ma'am.
Rajeshwari,
Present, ma'am.
Present, ma'am.
Ma'am, Akash present, ma'am.
yeah, Rakesh, Ramya,
ma'am.
Rashmi,
Present, ma'am.
Ravi, Rizwan,
Yes, ma'am. Yes, ma'am.
Vishal, Savita, Shruti,
Present, ma'am.
Sneha,
Yes, ma'am.
Purti, Srinidhi, Srinivas,
Srinidhi present, ma'am.
Sunil, Vaishnavi, Vidni. Yeah, I marked for everyone.
Ma'am, USN 13, Devmala ma'am, present ma'am.
Yeah, you can remind